Welcome to all. I am Assistant Professor Kute Akshada from SND Engineering and Research Center, Yeola. Today's topic is anodic protection. In previous lecture, we have seen the prevention methods of corrosion. These are one of the method of prevention, anodic protection. Feasibility of anodic protection is firstly demonstrated and tested by Anodic in 1954. Corrosion control of metal structure by impressed anodic current. Interface potential of the structure is increased into passive corrosion domain. Protective film is from on the surface of metal structure which decrease the corrosion rate down to its passive current. Can be applied for active passive metals alloys only. Process of anodic protection. First, simply anodic protection is based on the formation of protective film on metals by externally applied anodic currents. Second, it appears that the application of anodic current to a structure should tend to increase the dissolution rate of metal and decrease the rate of hydrogen evolution. This usually does occur except for metal with active-passive transition such as nickel, ferrous, chromium, tin and their alloys. If carefully controlled, the anodic currents are applied to these materials, they are passivated and the rate of metal dissolution is decreased. These are the diagram of anodic protection of steel storage tank containing sulfuric acid. This tank containing sulfuric acids. Reference electrodes are used, cathode anodes are used. The potentiostat has three terminals, one connected to the tank, another to an auxiliary cathode, and the third to the reference electrode. In operation, the potentiostat maintains a constant potential between the tank and the reference electrode. The optimum potential for protection is determined by electrochemical measurements. Polarization curves of anodic protection. Advantages of anodic protection. Anodic protection, unlike cathodic protection, is ideally suited for protection of active-passive alloys in aggressive environments such as high acidity and corrosive chemicals. Hence, anodic protection is the most preferred choice for protection of chemical processes equipment. These are log corrosion rate for current density. These are the graph. Polarization curves depicting the principles of anodic protections. If an active-passive alloy such as stainless steel is maintained in the passive region through an applied potential from a potentiostat, its initial corrosion rate in an active-passive alloy such as stainless steel is maintained in the passive region through an applied potential from a potentiostat, its initial corrosion rate can be shifted to low value as shown in this figure. Applied anodic current density is equal to oxidation current density minus reduction current density. Anodic protection parameters include protection range of potential in which metal alloy exhibits stable passivity, critical anodic current density, flood potential. Anodic protection can decrease corrosion rate substantially. Acid concentration, NaCl, corrosion rate protected, unprotected. These are the table. Metals which can be passivated and deactivated. The metals which can be passivated by oxidation and activated by reduction are those which have a higher oxide less soluble than a lower oxide and will thus each corrosion domain forms an angle. The lower the apex of this angle in the diagram, the easier it will be to passivate the metal by oxidation and it will be difficult to reactivate the passivated metals by reduction. Titanium and chromium can be passivated very easily and their passivation process will occur more often than not spontaneously even in the absence of oxidizing agent. These are the graphs. First is titanium, second chromium, third tin, fourth iron, fifth manganese, sixth lead, 7 silver, 8 nickel, 9 cobalt. Potential pH diagram for chromium. This diagram is the potential pH diagram for chromium. Anodic protection parameters. Range of potential in which metal is in passivate state. Critical current density, flat potential. Optimum potential for anodic protection is midway in the passive region. Increasing the chloride ions concentration results in a significant decrease of protection potential range. Consequently, in aggressive ions containing environment, anodic protection is applied only for metals which have relatively high protection potential and high pitting potential. Increasing temperature leading to a decrease of E. These are the schematic diagram of anodic protection system for protecting inner surface of storage tank. Comparison between the anodic and cathodic protection. First, in anodic protection, active passive metals only. In cathodic protection, all metals applicability. Corrosives, weak to aggressive. In cathodic protection, weak to moderate. Cost in anodic protection, cost is high. In cathodic protection, cost is low. Relative operation cost is very low in anodic protection and mediums to high in cathodic protection. Equipment, potentiostat plus cathodes, and in cathodic protection, scarificial anodes or DC power supply plus ICCP anode. Throwing power is anodic protection in high, very high, and in cathodic protection is very low. Significance of applied current is often a direct measure of protected corrosion rate. In cathodic, complex does not indicate corrosion rate. Operating conditions in anodic can be accurately and rapidly determined by electrochemical measurement, and in cathodic must usually be determined by empirical testing. Next, anodic protection has been applied to protect storage tanks, reactors, heat exchangers and transportation vessels for corrosive solutions. Heat exchangers, tube spirals and plates types, including their anodic protection systems, can be easily to purchase in the market. Thank you.